Let's learn about DHCP. What is DHCP? Dynamic Host Configuration Protocol. Okay. So why is it used for? This DHCP protocol is used to assign IP addresses dynamically to devices connected in the network. So imagine you have a very big office, okay? There's big office or school or college where you have a lab of 100 computers. Okay, so let's say this is one row. Here, like lab of 100 computers we have. Okay, so likewise there are different rows. So there is only 2 administrators here. What they have to do? So all these connected, let's say these are all our new computers. They have to, for these computers to communicate, what they need? Yes, they need IP address for these computers to be connected to LAN. And if they want to access the internet, for suppose this LAN is connected to the internet through some ISP. So they have to, so total, let's say 300 computers. And for each, they have to, there are 2 different ways to assign IP address. You can assign IP address manually. Okay, and dynamically. So manually needs a manual intervention. We need to go there and add details such as IP, net mask, and DNS gateway. These are different details, and there may be other extra details such as but these are essentials that are IP, netmask, DNS, and gateway. So these are all essential for this computer to connect with the local router, local LAN, and to be able to communicate or even access the internet. These details you have to go to every computer, and these details you have to enter there. And if there is any other extra information, of course you will have to provide that. But these are the bare minimum essential. But now tell me, let me open that open a packet tracer as well. So if you take, let me take a computer for you to show. This is to quickly show you. Okay, if you go to the computer and go to the configuration, IP configuration, what else? Minimum, you need IP address, subnet mask, gateway, and DNS. These are essentials you need. This is the static configuration. Static means manual. You will manually go to every system, open the software, go to the network settings, and then open the IPv4 settings, and there you will have to enter these 4 details. And this IP address should not be duplicate among all those 300 computers. The example we are discussing. DHCP is about a dynamic host configuration, and this is as opposed to minimum manual configuration. DHCP will acquire the IP address automatically. Okay, so that is the thing. So you look at this scenario. This is such a pain where we have to, let's say 1 minute it takes. So for these 2 people, let's say assume 1 minute it takes to travel to each computer I have, and how much time they have to spend, 300 minutes. Assuming 1 minute it takes. So much waste of time, and let's say you need to keep track of all that. This is unnecessarily a lot of work. But what if that is a manual configuration? What is dynamic allocation? Dynamic allocation that happens through DHCP. DHCP is a protocol as well as a client process on a host such as computers or mobile devices or any network device. And DHCP also runs, it is a client server applications. Clients run on the devices, network devices that are required network access, where whoever needs to obtain the IP address. Then and server usually DHCP server usually runs on a separate router, or usually we deploy separate server for DHCP that can be Active Directory domain controller, that has a Windows server, Active Directory enabled Windows server, which is a domain controller. Usually, along with the Active Directory, DHCP and DNS services will also run on that server. Okay, so what is the benefit of DHCP? So here, as discussed, for these all 300 computers, if you want to assign manually IP address, you need all these details and need to edit the configuration in each computer. But if it is a DHCP, through DHCP, as an administrator, you don't have to go to anywhere. You can sit in your cabin, okay, your cabin, and just configure this DHCP scope in a DHCP server, and reserve the IP addresses that are that are not intended to be leased, and then there you go. You don't have to visit any computer, because most of the computers, any devices, by default DHCP is enabled. So as long as they are connected with the network through wireless or wired, they acquire the DHCP. They acquire the dynamic IP through DHCP protocol from the DHCP server. So these are computers contain the DHCP client. They act as a DHCP client. Now let's look at what are the benefits of this DHCP. This is a centralized automated configuration. Centralized configuration, right? Because you can control from sitting in your cabin, logging into the Windows server, assuming Windows server is deployed, or any server that has a DHCP, or if that might be running on router. So we just have to tweak that DHCP configuration, and there you go. All other devices connected will get the IP according to the configuration. So you will be centralized configuration. You will be able to configure devices using central location, isn't it? So, and you can define a range, IP range. By defining IP range, you can allocate IP addresses through DHCP. And there is a lot of reduced, and it eliminates the manual error, human error. If you are going and configuring that 300 systems manually, you might do some error, and you will have to revisit there, and to check you are enter the just to nothing but to check the you entered subnet mask wrong, so that it is not able to communicate. But that is not that will be not the case if it is a DHCP, because it is according to the configuration, IP is given by the DHCP server. And even we can configure the DHCP relay agents. Relay agent is another service which will forward the DHCP request to another network. So DHCP, let's say you have a router, okay? This is a network, okay? So DHCP running on this network will only give IP addresses to all computers in this network. Okay, so but sometimes you can have a DHCP server on different network because this is a router. Connected, anything connected here is in different network. Anything connected here is different network. So you can have DHCP server. So in such a case, the router can be configured to relay the DHCP request. This router can be configured as a DHCP relay agent to relay DHCP request to a DHCP server in a different network. Okay, and this is easiest for the wireless devices and portable devices to be configured as long as they connected to the network. Okay, so those are the more than anything, it reduces a lot of human overhead, lot of work. So yes, these are all we discussed. What is, of course, with this we don't need to discuss about any of other things. More than anything, it reduces a lot of work, lot of burden, and it gives you a centralized configuration and central control over the IP allocation to the whole computers or devices in the network. How it works? How DHCP protocol works? Let's see that in action. So you have a computer. Let's say you have a router here. Okay, and DHCP server is here connected. So DHCP server is a computer in which DHCP server service runs. So it always listens. It is a server, so it listens for the request and response. So when a request is received by this server, and we have different computers connected. Phone is connected. Let's say laptop computer is connected. Laptop is connected. Okay, and some server is also connected. Let's say we have wireless access point. Okay. The wireless some phone is also connected. So all these devices, this whole thing is a network. One network, right? Network A. Let's go. So DHCP server. So we have DHCP server and we have different machines and they don't have IP yet. For any of this computer or device to communicate, they need IP. So not only IP, what they need other extra information such as IP, netmask, DNS, gateway. Otherwise, without you have IP but you don't have gateway, and it won't work because you should know default gateway to send packets when you don't know the route. We learn this during routing when we learned about routing process and routing tables. So what happens? Any of the clients, let's say this computer is turned on, it wants to connect with the DHCP server. What happens? And assuming this has a DHCP configured instead of manual or static, so DHCP enabled, it will get the IP during the process with the by the help of the process called DORA. Okay, so DORA is an acronym to remember uh, the to remember message, that to remember the communication, how DHCP and client and servers. Um, Sorry, let me rephrase. DORA is the process, that is an acronym to remember how client and DHCP client and DHCP server communicate. So it uses a DORA process. So which means that what it means, let's say you have the DHCP client. Client means what? Any computer, okay? Which can be anything, any computer or for mobile phone. And DHCP server is usually that runs on a router, or we can have a separate dedicated DHCP server. And example, we can enable DHCP server on a service on a Windows server. So this DORA, which means discover, offer, request, and A for acknowledge. So it uses a DORA process. DORA stands for discover, offer, request, and acknowledge. What does it mean? First, a client sends a discover DHCP message. Okay. So asking, it has no IP. Asking the server, sorry, it will broadcast. It will broadcast because as soon as you connected to the Wi-Fi, you don't have IP. It means that you can't communicate and you don't know where on which IP DHCP is running. Let's say it is running on 192.168. It doesn't mean that DHCP is available always on 1.1 or 2.1 IPs. Okay, so assume DHCP is running on 192.168.4.21. So a device, a mobile phone connected through wireless, don't know IP address of this DHCP server, isn't it? So in such a case, what happens? What is a special IP address called 255.255.255.255? What is this IP? No, this is limited broadcast address, not multi-broadcast address. It is limited broadcast address. So all ones, which is limited broadcast address, it means that it will all computers in the network. That broadcast domain is limited by the router. Okay, so it means, what does it mean? This router, it has a separate network connected here, another network B, let's say B is connected, but here any computer sending messages to 255.255.255, which means that limited broadcast, it means referring all computers in the network. Limited by this, the broadcast domain is limited by the router or particular network. So which means all 255 means referring to all devices in the network, which is a broadcast. So it will broadcast this discover message to all computers in the network. So how it goes? It goes like that broadcast goes to this tablet. This broadcast goes to, again, this is laptop. Okay. So this broadcast goes to this tab, and again this laptop, this mobile phone, and even this server. So what happens? Any device that receives, all devices will receive the broadcast, but devices uh, that are not having a DHCP service running, they simply discard that packet, not package. Okay. On which port client runs DHCP client runs on usually DHCP client runs on port 68 and DHCP server runs on a port 67. Okay. So DHCP is application layer protocol on top of UDP. DHCP uses the transport protocol UDP, not the TCP, because it is time sensitive. For speed is more important than reliability. Okay, like for DNS as well. Okay, for DNS uses both TCP and UDP. But here, uh, just in case it is why UDP is chosen, because discover request DHCP client may send messages to the server. If they are lost, DHCP service is designed in such a way that will ask the discover again. Okay, that will ask for the IP with the discover request again. Likewise, lost packets are retransmitted and that is handled by the service, not the UDP service, but the DHCP. So, yeah, this DHCP is uses the transport layer protocol UDP, and the client runs on the port 68, server runs on the port 67. As we are discussing that, this is received by all systems, but all will drop that packet except the server. So this server is what? This system running on some IP 192.168. Which IP we use there? 4.21. It is a DHCP, so that it will not drop that packet. It will respond with the message offer, DHCP offer, offering, okay, do you here I am the DHCP server, can you offer this IP, so on so IP to the client. After client receives DHCP client, that is a client process running on either phone, laptop, tablet, will respond with a DHCP request, requesting yes, give me that IP. Requesting, let's say it is it offered some IP called 192.168.4.45. Okay, 4.45. So it will request, yes, okay, if you have a it will respond with the same IP, requesting the same IP, whatever is offered in that DHCP offer. Oh yeah, so you are the DHCP server, please give me, please here I'm requesting you to release so and so IP. It means, so after request, if DHCP server it is for the consent of DHCP server, if DHCP server will check in the scope, and if that particular IP is not assigned to any of other systems, it will respond back with acknowledgement. There you go, as you have requested so and so IP, yes, it is available, I grant you, I lease you this IP for so and so days. Okay, here lease means the IP DHCP clients request the IP, those IPs are leased by DHCP server, which means that those IPs are and these DHCP clients have to renew that IP during that lease period at least for 3 times if they have to if they want to retain that IP. We will see that thing in action, in some time. Do you understand? Let me summarize this process. First, DHCP client will broadcast this with the to broadcast to all systems in the network, and to all systems that are not DHCP servers will discard those packets, and DHCP server will reply back because since imagine here this client is not having IP until this is assigned here. Okay, after acknowledgement only that IP is assigned. Okay, assigned to client. So until then, the client is not having any IP to communicate. In such a case, DHCP server identifies the DHCP client by making use of MAC address. Okay, what is MAC address? Which is a physical address. Okay, address is used to identify this physical address, or MAC address is used to identify what? A client, DHCP client that made the request. Okay, now there you go. So, and there is another thing, it will use MAC address as well as a transaction ID. Transaction ID is in the DHCP protocol that we will discuss in a moment. After we see this whole process in action. So DHCP server issues IP. So optionally, this is optionally, if DHCP client wants any more information after acknowledgement, it will ask that information using DHCP info. Information that can be about other than IP net mask. Okay, about lease or any other information. So optionally, it can get that information through DHCP info. And there are other messages as well. We'll see them in action. But before we proceed, let me summarize the whole stuff we have learned. DHCP client, that service runs on that DHCP client is available on almost all network devices from phone, tablet, laptop, and mobile devices. And as soon as you connect, for example, with a Wi-Fi router, DHCP dynamic DHCP service on the device gets the IP through DHCP by making use of DHCP protocol. So 3 things here you need to understand here. 3 things are involved that are DHCP client, which runs on network devices, and DHCP server, which is a process runs on a DHCP server or a router, and we have a DHCP protocol. Okay. So what we have learned here is a DHCP protocol. So DHCP protocol, we can remember that conversation using acronym called DORA, which means discover, offer, request, acknowledgement. Client will ask first to discover the DHCP server, it will broadcast, and then we'll get the usually offer will come from the DHCP server and will request the IP, and acknowledgement is provided by the server. And after that, client will get the IP. Until client gets the IP, server identifies the client by making use of the MAC address and transaction ID. And there is a lease time. What is a lease? lease is the specific time for that specific time, length of the time that the client can, yeah, client can use the IP. So client has to renew that IP. It must renew that IP address periodically during the lease period. And if that IP is not renewed, what happens? That IP is not renewed. Uh, server will maintain a record of IPs that are leased. So any client that has a particular IP hasn't sent any renew, DHCP renew. What happens? That IP will be taken away, which means server will remove that from assigned list and it will be used to reassign for other devices. So this whole thing, let's see this whole thing in action using Wireshark. So this is this Wireshark, this file I have downloaded from sample captures, and there you search for the DHCP. Okay, so this is a file I have downloaded. So you can download, you can get this file from here. It is very simple. It has nothing but DHCP. And we can see, and more than anything, we haven't discussed, DHCP is an extension of BootP protocol. BootP protocol. We'll see this as we discuss, as we evaluate as we try to understand packets, a DHCP protocol and a Wireshark. There we will see that references of BootP. So it is an extension of BootP protocol, DHCP is. And there is a, and you can, and also display filter for the DHCP is BootP, not the DHCP. Okay. So since we have already 4 packets only, remember always as you open, after you open the packet, sorry, not packet tracer, Wireshark, please go to the packet protocol hierarchy, and there you can see the different layers on how it is encapsulated. This is application layer protocol, which is DHCP, dynamic host configuration protocol. We can see in this file we have 4 packets of that is encapsulated into UDP. We discussed that DHCP is based on top of UDP. It uses the UDP transport protocol, and then it is encapsulated into IPv4. And also we have 4 packets, and then it is encapsulated into a frame of a data link layer. And this frame is Wireshark uses as a pseudo protocol to represent the packet. And we have only 4 packets. So that is the reason you see 4 packets for all kind of protocols. And you can see here, as we discussed, first, let me go through analyze statistics, and there you can go flow graph. There you can see how flow graph or Wireshark painted this flow graph, and I'll explain this in a moment. There you can see what you see here, 67, which means that what? See, hello there, can you hear me? Okay. Yeah, so you can see this all 4 packets are illustrated using flow graph. That is quite pleasant to understand, to look at the flow graph. This whole information is whatever we discussed here so far is presented using flow graph. As you can see here, what happened? First 0, 0, which means that client is not having any IP. DHCP client on 68 port, UDP port. Sent a request to DHCP server, or this is a broadcast. This is a broadcast, but all other broadcasts are not captured here. But you can see that broadcast was sent to IP call 255.255.255.255, which is a special IP, which means that these packets are sent to all computers in the network. But the one computer that is a, that is actually the DHCP server replied back. Replied back with the offer. Can you see here? Which is 19.168.0.1. Okay, this is after this. After this, this is the request, DHCP offer. Okay. So Wireshark just displayed it. This is the same thing we discussed here, but Wireshark displayed like two messages because it separated that, because 255 is different, and here it server responded by the time this communication it got the IP. Okay, anyway, I hope you understood this. So we have DHCP server IP, which is server port 67, replied with the DHCP offer. Can you see here? And DHCP client client that has client that is not having any IP as assigned sent a DHCP request after the DHCP offer, requesting that particular IP, and then we got the acknowledgement. After acknowledgement, that server got configured with the IP mentioned here. Let's see that in action here using packet. We'll see that using packet tracer as well. But look at this thing here. So this is a broadcast. Can you see? Destination address is 255, 255, 250. And you can see here Ethernet frame and the IPv4 protocol, and then UDP, and then dynamic host configuration protocol. Can you see here boot request, message type is boot request. And you can see here boot P flags. This is an extension of boot P protocol. And there you can see client IP address here is 00, which means that client is not having any IP assigned. So client doesn't know its own IP yet. So, and here client MAC address is included. Can you see? So when packet is sent in our discover, this is to broadcast. This is the broadcast, right? So here, client, this packet, DHCP packet doesn't know client IP, but it doesn't know server IP, right? Server IP is, its own IP is not known, but it doesn't know server MAC address also. It knows its own MAC, right? So its own MAC is included. So what packet is sent? Discover is sent, is broadcasted, and server replies back with the including its own server MAC address. Still no IP is included here, client IP, and server replies back with server IP as well as a server MAC. Okay, this is a client MAC, server MAC. Do you understand? Look into that in detail. So here MAC address, MAC or hardware address, client hardware address is included because As a respond, DHCP offer will be sent from the server. But remember here there is a transaction ID. Can you see here where is the transaction ID? Here it is. For all these DHCP requests, for all these communications, because since UDP is connectionless protocol, unlike TCP, so each request is altogether different. So how do you keep track of this offer request, offer reply is for this discover request only, because the client may send multiple discover requests. So in such a case, client will choose some random number for the transaction ID. So subsequent messages that are received by the client with the same transaction ID are assumed uh, as a single conversation, all combined. So server replies back with the same transaction ID. Now, as we discussed, can you see here previously what is the IP? Destination IP. We don't know source IP. We don't know destination IP. Only source MAC is known. But in a response, can you see here the source IP, which is 0.1, which is a gateway, and then destination IP. Can you see here client? It is Wireshark did some work here to present us in a better way for us to understand this conversation effectively. So here you can see here what is server IP. Server IP is included. If you go there, server IP is not included here. Relay agent IP is not included. But in a reply, there is no relay agent here, but server IP is included. And server MAC address is also included. Here there is a your IP. So if you go here, it is a DHCP message type offer, and you can see this information server is providing all that information. MAC address, isn't it? Can you see? Sorry, not MAC address, subnet mask. And the renewal time. What is renewal time? 30 minutes. Okay. Rebinding time, which is a 52 minutes. It is leasing. Okay. Then IP address. You see here IP address. What is the lease time? 1 hour. Okay. So pretty much usually it could be up as much as 7 days. Okay, and then we have DHCP server identifier, which is a server IP. Can you see? Server IP is included. And the server MAC address is known because based on this, using this Ethernet protocol, we know that this message is coming from some particular device, that destination MAC address, source MAC address are included in the data link layer frame. So based on the message that is received by the DHCP client, it can also determine from which MAC address or from where this message came. So in a response, we would know the server IP as well as MAC address. And also some information is offered here. In a reply, the server will provide all these details. What are those details? These details are provided by server, all these details. Okay, so that we can see here in action. We can see, right, in our offer, server replied with IP and net mask. Okay, and then you can see here this can be a broadcast or this can be a direct message. Okay, so but again it broadcasted with the broadcasted DHCP request, or this can be, do you understand? So this may, so here according based on the IP it is a broadcast, and in broadcast, can you see here the client is requesting the same IP. We can see here in a message identifier, which is a request, client identifier, client is identified by its MAC, and since it is a broadcast, you can see in a broadcast destination IP is a 255.255.255.255 and destination MAC address will be all Fs, means all ones. Okay, and DHCP server identifier, and where is this one? Let's go. Can you see here DHCP request IP? Can you see? Server is DHCP client is requesting the same IP that was offered, isn't it? Hello? Yeah, requested the same IP that was in the offer, and then you see acknowledgement. There you go. So server acknowledged the client to register to get itself assigned to that particular requested IP. You can see here DHCP. Now there you go. You see the subnet mask and you see the lease time. Okay. Yes, yes. Rebinding time, and there you go. Any questions you have? No. Okay. Let's discuss this thing. Let's see this whole process in action quickly. Okay. So I have a PC, I have a laptop. Okay. Yeah. So let's add a server. Okay. And what do I need? I need a switch because I want to assign multiple devices. Yeah, I wanted, since I'm connecting multiple devices, and I took the switch here. Yes, we need a router, and I'm connecting this packet, this server as well. And now let's take where is router? So all these when we configure these IP addresses, so when these IP addresses are configured, range of IP addresses are configured in our DHCP server, we call them as scopes. DHCP server issues IP address to these all clients, DHCP clients, based on the scope that is defined by the administrator. So who will define this all scope and range? Administrator, like you. Okay. So now if you go here, see, by default all systems are configured with to use DHCP. Okay. Now go to DHCP server. Let's say first let me connect with this router. See, I can go directly there. I can add commands, or I can come here directly, configure the port here, FS00, 4.1. Subnet mask I'm giving 255.255.255.0. Okay, and I want this interface to turn on, which is a no shutdown. Okay, so we took the 4.1, the 4.0 network it is. Now go to server, and there we are defining desktop, sorry, services, and turn on the DHCP. Turn on, it is off, turn on. And can you see DHCP uses pools? So what happens, you can ask one thing. Let's say I have a different, let's say you can ask one question, that is here we have different systems. You may ask, let's say uh, we have another server, which is a web server here. Web servers do need a static IP. Okay, because dynamic, whenever, you know, if you are getting this IPs assigned through DHCP, this dynamic host configuration protocol, your IP may change every time you connect, but usually that is the most of the time we get assigned the same IP. But otherwise, the IP you get through DHCP is not guaranteed to be static every time you get the IP. But web server, we need a static IP, because if you want to communicate, we need that IP to be static, because if you configure that in a DNS, so let's say example.com. So if I configure that with the DNS example, some example.com or some website.com, it is. So in such a case that you are using, that might be internal or external. In such a case, you don't want that IP to change. Otherwise, if that IP is changed, the domain will resolve with the old IP, and that uh, the website may not or will not work. Do you understand this one? So in such a case, we don't want this to be to get dynamic lesson, so that we will assign IP here manually. But you may there is another question. What if this IP, I assign the static IP here for this one, 192.168.4.55. It's a static IP. I don't want this IP to be leased to any of other devices. What happens if two devices in the same network get the same IP? It will be a chaos, because packet will be dropped and packets will not be delivered properly. So we don't want this IP to be leased to any of other devices. In such a case, we want to reserve that IP. Okay, so we can reserve those IPs. We can also define the IPs IP range to reserve particular group of addresses. That is we can see here also. So we define there is a server pool. So see here, I'm giving these details 190.168. See this, whatever I'm doing in a DHCP server. 190.168.4.1. This is a gateway, right? Default gateway. That is the IP of router. And what is DNS? Let's give DNS also 4. And here is this is the IP range or a scope we are defining. Start IP 190.168. Okay, 4. Let's give the starting IP 40. Okay, and what is subnet mask? 255.255.250. Okay, maximum number of users, let's give 20, which means that the last IP would be 60. Yeah, 0, sorry, last one is 0. And you can give some extra information, which is like a TFTP server, WLC server. These are some extra information other than the 4 values. Do you get it? Default gateway, IP address, DNS. Okay, default gateway, DNS, IP address, subnet mask. These are 4 are essential. Other than that, there could be some other extra information DHCP client may request that include EFTP server or WLC server, some other extra information. If required, the client can request that extra information through DHCP inform message. So I'm saving this. I have saved that one. Okay. Now go check IP configuration. What is this IP? This is a link local IP address. Remember, special IP addresses or here you can see link local IP address block. Any IP from this block is assigned to the network card by the operating system if it is not able to acquire the IP. So here thing is that tried DHCP, you can see this message, DHCP failed and APIP, automatic private IP message is used to assign the IP address. Okay, now let's do the simulation, how it works. This is one network, right? Let's do the simulation. Fill color. This is one network. And since we don't have any IP here, they can't communicate because PC has no functional ports. Go to the simulation and I don't want any of okay, so you can see the ARP as well in such a case, but let's see. So go to the IP. DHCP, go static and dynamic. Is requesting IP. Let's play this one. Requesting IP. Can you see this one? This is a broadcast. Can you see this? The broadcast, which is a DHCP request. Let me pause this one. Okay, it is going. Let's. Okay, first thing, I have done some mistake here. Let's turn off this. Basically, I did a mistake, terrible mistake, which is I configured this service here, DHCP, but I haven't assigned a IP to DHCP server. This is a DHCP server, isn't it? It needs IP. So it won't get IP from another DHCP server. We need to assign some IP, static IP. 190.168.4. What is it 41? Which one we took in our example? 4.21. Okay. Let's assign 4.21. Default gateway 19.168.4.1. DNS server. We don't have DNS server here, but that's fine. Let's leave it to 4.1. Okay, now let's do the simulation again. Get this PC. See, this is automatic private IP address. That, what is it called? Link local address. It stands for automatic private IP addressing. In such a case, this IP can be used. Two individual computers can have this IP assigned and they can communicate using that IP without other any router or without those systems connected in the network. Okay, so usually if you look at this IP, what you can understand, you can infer that DHCP failed. It tried to acquire the IP through DHCP, and uh, that system failed to get the IP through DHCP, so that itself assigned API address, automatic private IP addressing, which is a link local IP from the block 169 to 54. Now we have given IP 2.4.21 to this DHCP server. Now let's do the simulation. Play. Okay, this is going on still. Okay. Enable only those two protocols. Let's delete all events. Go to simulation, open this, and get the DHCP server. Play, and it capturing that, and click on DHCP. It will try to get the IP. Can you see here now? It will be broadcasted. See, this DHCP request is getting broadcasted. And can you see here what happened? Only server received, and can you see this server replied with the DHCP offer? Okay, I can pass this here and let me open that. This is ARP. Yeah, here is the DHCP. From server received that. These green brackets are ARP. Okay. So ARP is used to resolve the IP into MAC address. And you see DHCP message, which is being sent, which is a DHCP offer, which is again a broadcast. You can see went to all, but all discarded that because they are not intended for those systems. Only this machine received. And all other discarded again, and replied back with DHCP server replied back. And can you see here? Now this server acquired IP already. Sorry, this machine. Can you see 4.3? Can you see DHCP request successful? Can you see that? Okay. So if you go here, IP configuration, and this one, go to static. Let's delete everything. Go to static, and if I click on DHCP, and there you can see whole process again. Now this laptop See, this laptop is not having any IP at the moment, requesting IP, you can see. This is the broadcast, DHCP offer. Sorry, DHCP, DHCP offer it is, which is a broadcast, and yeah. So DHCP discover, first it is sending, and then offer we are getting, and that request acknowledgement. So first, let me delete. We'll wrap this thing with this the static IP. Let me delete everything. Okay. This is not having any IP. If I click on DHCP, requesting IP. Check this one. First one, which is a Discord, because it doesn't know where is DHCP server. All other intos, can you see? Into means what? Yeah, packets are dropped because they are not destined for that. Okay, all other dropped because it is a broadcast. Then server will reply with the offer. These are ARP packets, that is to resolve the IP to MAC. And now you see here reply went all other packets discarded, which is offer. After offer, client is requesting. Can you see? Okay, and then server will reply back with the acknowledgement. And there you go. This will get the IP. Can you see here? DHCP successful, got the IP. And if you do, this pool can be controlled from Go services, DHCP, and we have assigned, this is a pool from the first IP I am assigning from 0. Let's say 20. So I don't want these IPs to be assigned from 0. I want these IPs to be assigned from 45. So there you go. Save. I updated this IP range. Now next time when I try to get the IP for any system, it will get the IP from the scope I defined there. Okay, and I have given here, have provided other details, but only reserved 20 IPs to be assigned from 45, which is a 65. So in any case, in that case, if you all other IPs that are not included in this pool will not be used to assign IP address dynamically, or they will not be leased. So other IPs that are not included here, we can use freely to assign them as a static IP address to any server. Can you see? Can you see here now what is new IP? Can you see 4.47? Can you see 47 here? Why is it 47? Because I updated that. 47, 45. DORA discover request. Sorry, DORA request. I'm sorry again. Discover, offer, request, acknowledgement. Do you remember Dora? Dora the Explorer. Yeah, remember her. Remember this. Yeah. Okay. So Dora the Explorer. Like our DHCP client is exploring its own IP. Discover, offer, request, acknowledgement. Yeah. I hope you understood. You don't have any questions about DHCP now.